Hi, this is Juan from JuanTutors.com. We're working on the August 2016 New York Geometry Common Core Regents, problem number 2. If you want to access these exams, go to nysedregents.org, click on the appropriate tabs. So here's the problem. Which transformation would not always produce an image that would be congruent to the original figure? Translation, dilation, rotation, reflection. Definitely pause the video, try it on your own. You want to test yourself to see if you can get the answer. And then once you get the answer, see if you get the same answer as we do. If you do, definitely hit the like button so that we can know that your answer agrees with ours. So let's see. The choices are translation, dilation, rotation, and reflection. Now, this is an important problem. They do like to ask this kind of question, and we should really be able to eliminate choices. So would not always produce an image that is congruent, okay? So let's see. Translation means a sliding of a figure. That should not change the shape of the figure. So that should not be the answer. This does produce an answer that's congruent to the original figure, so that's not it. A rotation is a turning of the figure. It doesn't change the size of the figure. So rotation does not does preserve congruence. And then a reflection also just flips a figure, but everything stays the same size. So a reflection does produce a figure that is congruent. So in fact, the answer has to be a dilation. And truly, in this question, this is supposed to be a kind of a gimme question, meaning if you read the question, you're supposed to kind of, if you just pause and think about what the meanings of these words are, literally force yourself to think individually, one at a time, what the meanings of these words are. You should be able to get the answer. A dilation is a changing of the size of the figure, which is literally a way to eliminate congruence, because congruent figures are the same size, same shape. So that's the answer. Let's see if we can get an extra problem here. This is one that was created by us here at JuanTutors.com. Which of the following would not always produce an image that would have the same orientation of the original figure? Translation, dilation, rotation, or reflection. So again, pause the video, see if you get the same answers. Let's try to remember what the word orientation is and see if you can get it. If you get the right answer, definitely hit the like button, subscribe, and definitely let your friends know that we're here. The reason we're here is to help students like you get ahead in this kind of class. And seeing that students like you are watching these videos definitely motivates us to make more of these videos. Let's define orientation in a plane. Definition, and this is a workable definition. So the orientation, okay, of a shape, let's say of a polygon, okay, in the plane is the ordering of the vertices of the figure in a counterclockwise order. Okay, so like for example, if we have a figure, let's say we have a triangle here. Okay, not necessarily a right triangle obtuse acute, it's just a triangle. Okay, so if you read the vertices of this triangle in order counterclockwise, then we see that if we start at the lowest letter A, then we go to B and we go to C, and that's the arrangement of these vertices in the plane. So a translation, which is a sliding of the figure, does not change the ordering of the vertices. In fact, it changes nothing about the figure other than its position. So it's a translation does not change the orientation. A dilation just changes the size of the figure. It makes this object bigger or smaller. It doesn't change the ordering of the vertices if all it does is this. And in fact, the dilation with a negative size, it does this. So which seems to maybe possibly flip the ordering. But if we look at a dilation of a negative side, let's say the center of dilation is there, then the figure would get dilated here, let's say here, A prime, then B prime would be like here, and then C prime would be here. Okay, and this could be a dilation, a negative dilation. A large number, small number, doesn't matter. The point is that it's a negative dilation. And if we start at A prime and go in the counterclockwise direction, we see that the ordering of the vertices is A prime, B prime, C prime, which is the same ordering as the original shape ABC. So a dilation, even a negative dilation, does not change the orientation of the vertices. So that's not that does not change the order of the vertices, and we're looking for does not produce an image that has the same orientation. Now, a rotation also cannot change the ordering of the vertices, because if we're turning all vertices in the same direction, then the arrangement of the vertices in a counterclockwise direction cannot change. So that's not the answer. So the answer has to be a reflection. Okay, so let's look at this an example of a reflection of this figure. So if we reflect this figure, I'm going to draw a line right here. Okay, and I'm going to reflect this figure over this line. So this B is going to go here to B prime. C is going to go here to C prime. And then A is going to go here to A prime. And then we have this shape as its image over that line. So we're doing an example of a line reflection here. And the original ordering of these vertices in the counterclockwise direction was A, B, C. So if we start at A, and this figure, we start at A prime. Maybe we should add a second prime here. Okay. Then we start at A double prime, and counterclockwise we end up at C double prime and then B double prime, which is a different order as before. Whereas before we went A, B, C, now it's A, C, B. Different order, different orientation. This is a reverse orientation. So this does not, the reflection does not always produce an image that would have the same orientation as the original figure, and that's the answer. Hopefully you got this. Listen, it just takes a little bit of work. Keep working at it. Keep watching these videos, and if you got the right answer, or if these videos are helping you, hit the like button, subscribe. You know, the reason we make these videos is to help students like you. So definitely we appreciate you watching, and thanks for watching, and stay tuned for the next video starting right now.